Hey, amazing students. All right, guys. So we're actually drawing near to the end of quadratics with quadratic regression. And this should sound familiar because we did the same thing with linear regression. And what that is the line of best fit. Or I guess really the parabola of best fit. So for example, if I had some data and it wasn't going to make a perfect parabola, but you can tell it's in the shape of a parabola, and we want the line that best fits our data, right? That would be called the quadratic regression line. So what we're going to do is when we get our line, Desmos is going to do it for us. We're going to use that equation to make predictions. And so if you remember, the standard form for quadratics is y equals ax squared plus bx plus c. But if we want to do it in quadratic regression, we want Desmos to give us the answer. We're going to add a table, put our table in, put the points in, and then do y1 squiggle ax1 squared plus bx1 plus c. So you're just replacing with whatever the title of the tables are for x and y and the equal sign. So this is just like linear regression. So let's look at our first example. A projectile is launched into the air from the ground. Well, the table shows the height of the projectile h of t at different heights. A lot of people may ask themselves, well, after we do quadratic regression, linear regression, exponential regression, you'd be like, well, wait, which one am I doing? Which regression am I doing? And you have to think about the example. A projectile is launched into the air. Well, if something is launched into the air, it has to come back down, yeah? So knowing that, I know this is talking about quadratics. So we have to think about what it's referring to in real life to know whether it will be linear, quadratic, and you'll be introduced to exponential later. Based on the table, which function can be used to model this situation? Well, we're going to put this table into Desmos. So plus sign, table, 5, 10, 15, 20, 25, 30, 35. Let's see if I can do this. 1,353. I can actually just go. 2,460. 3,023. 3,940, 4,313, 4,440, 4,323. So notice my x and my y both have 1 as its subscript. So let me show you what I'm doing. y1 squiggle ax1 squared plus bx1 plus c. So when I do this, I wonder if I can zoom out. I'll give you a good one. It's going to be pretty high up there. You'll see the parabola going up and then going back down. But here's your A, your B, and your C. So your A value was negative 4.9. Your B value, 294.9. And your C value was roughly around 0.57 or 0.6. So I'm looking at for these A, B, and C's, my answer would be B. So it's literally letting the Desmos do the work for you. Okay, let's do another one. An object is launched into the air. The table below shows the object's height above the ground at various times. Again, an object is being launched in the air, so it has to go up, but what goes up must come down at some point. So we need to figure out the equation for this data. So, excuse me, plus sign, table, 1, 2, 3, 4, 5, 6, I believe. 78, 109, 131, 143, 145, and 137. So let me zoom. Let's see what it looks like here. Okay, so you see this is the graph. Oops. Let's zoom a little bit out, a little bit more. Okay, and we want to find its equation. So y1 squiggle ax1 squared plus bx1 plus, hey, c. All right, so there's our A, there's our B, and there's our C value. So our A value is negative 4.9. Our B value, 46.2. And I usually just kind of round to the nearest tenth place. You want to be as accurate as possible, so honestly, probably rounding is not the best idea. And C, 36.5. So let me write my equation. Y equals negative 4.9 x squared plus 46.2x plus 36.5, right? I put the A, the B, and the C in their respective spots. Now, let's look at the question. Based on the table, which of the following is closest to the object's height? So I'm looking for its height. So I'm looking for the Y value. Above the ground, 9 seconds is my X value after being launched. So if I'm looking for Y and it gave me X, what do you think I'm going to do with this X value? Plug it in, plug it in. So negative 4.9, 9 squared plus 46.2 times 9 plus 36.5. Do I have to do all that out by hand? Absolutely not. So, negative 4.9, 9 squared plus 46.2 times 9 plus 36.5. Gave me roughly 55.4. So Y equals 55.4 meters, giving me B as my closest answer choice. Okay, last one. Pause the video, put the table into Desmos yourself, find the equation, and then let's look through the answer choices, okay? What do the following statements is true about the graph of G? Well, I'm going to go ahead and just graph this, okay? So I'm going to cancel all this out, add a table, negative 1, 2, 5, 6, 9. And I'm using my keyboard, guys, so that's why you don't see me clicking anything. It's just faster for me to do on the keyboard. Negative 55, negative 16, 5, 8, 5. And guys, yeah, we really do have to learn how to utilize Desmos, not rely on Desmos, but how to utilize it best, especially when we're looking for graph features. So here are some points. You can see the parabola right here. Let me do my Y1, squiggle, AX1 squared plus BX1 plus C. And I know I did it really fast last time, so in case you missed it, Y1 squiggle AX1 squared plus BX1 1 plus C. Okay. All right. Oh, beautiful. So you notice all the values are whole numbers. So we have the equation y equals negative 1x squared plus 14x plus 40. Oops, I think I lied. Minus 40. All right, now let's look at what this is saying. Which of the following statements is true about the graph of G? Well, I can just look at my graph, right? Let's look at some features. What's the x-intercepts? I have an x-intercept at 10 and an x-intercept at 4. What's the vertex? 7, 9. So what's the axis of symmetry? X equals 7. And this is a downward facing parabola, hence why my A is negative. Okay, so all of that stuff you should be able to point out. So the graph has a line of symmetry at x equals 7. That is true, right? Because the vertex is at 7, 9. So that x value is at x equals 7. That will split it in half. Has a y-intercept at negative 40. Well, I know that because that's my C value, but for those of you who don't remember that fact, I can just scroll down. There's my y-intercept at negative 40. So it does have a y-intercept at 0, negative 40. It has an x-intercept at 4, 0. Let's look at our x-intercepts again. We have an x-intercept at 4, 0 and 10, 0. Not really sure why I stopped the graph. And the graph has a vertex at 6, 8. No, we know the vertex is at 7, 9. So we know that 1, 2, and 3 are correct. All right, guys. So that is quadratic regression. If you have any questions, please let me know. Have a great day. And make sure you practice using Desmos on your iPad.